Okay, so we're looking at a still from the JTolan video from YouTube, claiming to show a 100% flat Earth from a height of 10,000 feet with his infrared camera. Nice camera, by the way. So, this is the view. The first part of the video, he's pointing out some landmarks which he claims are 1,000 miles away. There's plenty of people in the comments already uh, saying they live there or they have lived there, and those aren't the landmarks he claims they are. And in fact, they are proving that with Google Earth. So we won't talk about that because, as you can probably tell by my voice, I'm not from the US. I don't know the area, and that's purely conjecture on Mr. Tolan's part. So we'll leave that out of it. What we'll look at is the flatness or curvature, however you want to see it, seen out the window. So this is a still from the video, and it looks pretty flat. He's right; it does look flat. Let's have a look at a straight line on there, drawn over the horizon. So it's fairly flat, but you can see a little bit of curvature. You can see a little bulge in the middle there. The line's touching the horizon this side, it's touching the horizon on this side, and there's a very slight curvature bulge in the middle. Now you could say, okay, that's often excused by flat earthers as the curvature of the airplane window distorting the image. We can kind of test this out. None of this is particularly scientific, by the way, but then nor is the original video. So if we put some lines on the wing, we can see, excuse me, they match up. Those lines are straight, even, sorry about that, no difference with the straight lines than with the angles of the wings. So unless the window is being particularly choosy about which straight lines it wants to distort, then window curvature is probably not the explanation. But the curvature is very slight, and flat earthers will say, well, you should see more of a curve from up there. Look at how much the horizon should drop away. So let's have a look. Again, not particularly scientific, but a scale model of what we should be seeing. And let's match that with the reality of what we do see out the window. So this is a globe, represents the globe. I've drawn this to a scale of 1 millimeter to every 10 miles. You can see up here the diameter of this circle is 791 millimeters, because the Earth is about 7,910 miles wide. So 1 millimeter, 10 miles. At the top here, if we zoom in, let me explain what we're seeing. This blue bar in the middle, that represents the altitude at 10,000 feet, which is about 1.9 miles. And you'll see from this that is 1.9 millimeters high, that little blue bar. So the top of that blue bar represents the height of the observer. This large pink box, this wide one, this represents the full angle of view that you'd expect to see on a globe Earth. Calculating that using the horizon calculator on here, at 10,000 feet, you'd see a horizon of 122 miles. So 122 miles, that's around 12 millimeters on our scale. So I've doubled that because you're seeing both ways, and so the complete observable horizon should be 24 millimeters on this scale, with a full 180-degree horizon. Now you're not seeing that, of course, from the window of the plane. You're seeing what the camera is allowing you to see. The focal field of view, excuse me, of the camera. Couldn't actually find that out for that particular model. Had a search, couldn't find the exact, but it's around varies around sort of 80 degrees or so. So I've erred on the larger side, just to be fair, and size this at a 90-degree angle, which would be half of this 180-degree box here. That was 24 millimeters. This is 12 millimeters wide. So that's our field of view. So I've taken the image, scaled it to the field of view, and dropped it against our globe. So this is roughly the curvature you would expect to see at that altitude with that kind of field of view. And lo and behold, if I just lower the opacity down of this, we should see that matches pretty much exactly what we are actually seeing in reality. Ignore the straight blue line at the top here, that's the bounding box of this circle. This lower blue line is the edge of the circle that runs around there, and it matches bang on actually with the horizon that we're seeing in the image. So what does this show us? Does this prove a globe Earth? No, not exactly. It proves that we're seeing what we expect to see on a globe Earth. But does it prove a flat Earth? Absolutely not. This video does not prove a flat Earth in the slightest. In fact, it proves the globe Earth more conclusively than the flat Earth.